Welcome back. It's been 3 days since we last met. Okay, so it's been a long time since we did number 11. So let's do number 12. I know that you're all very sleepy. No, I'm just kidding. We were just like a minute ago. Okay, either that or wear the same clothes too much. Okay, so what do we got? It says, write the following in index form with a prime number as a base. 16 and 121. So what do you think? Anybody? Get you? When you start playing with your pencil case, I know that you're not very interested. So try to focus. I know that's near the end of the day, but we have like 45 minutes left, 43 minutes left. All right, so what do we got? 16. A base is a prime number. Yes.
The answer is 2 to the power 4.
Okay. That's right. What about 121?
11.
11. Very good. 11 squared. Okay. Easy? No?
Yeah.
You gotta think about that one, don't you? Okay. What about number 13? All right, listen very carefully. Shall I put this up on the screen? Can you read this? Can you read that? Is that up there? All right, somebody read that out loud while who can read well? Well, just read it. Yes, go ahead. This is number 13. And I'll repeat what you say. Suppose the garbage man visits your house
once every 14 days.
Once every 14 days. Wow, man, you must have a lot of garbage.
And the gardener visits your house once every 10 days.
And the gardener visits your house once every 10 days.
If they both visit your house today,
If they both visit your house today,
how long will it be before they both are at your house on the same day again?
how long will it be before they're both at your house the same day, right? What do I smell? I smell something. No, not really. I'm just kidding. I mean, they're all like going, no, I smell something relative to what? How do you do this? Any idea?
What's covered up 14 times 10 and then divided 7.
Well, are you suggesting that it's least common multiple? Is that what you're saying? Least common multiple? Or greatest common factor? Is it highest common factor? I call it greatest common factor. So some of you who came from different schools, highest common factor and greatest common factor. And what about least common multiple? So is it one of those, do you think? Which one? What do you think it is? Yes. What is it? All right, so what are the two numbers? 14 and 10, right? What are the primes for 10? 2 and 5, right, good. And what about 14? 2 and 7. So what's common?
17.
What's common? 2. 2. Come on, guys, let's go. 2, 5, 7. Correct? All right. So, what? What's the greatest exponent for 2? 1, right? How about for 5? 1, 7. Okay, good. So what's the answer? Is that right?
Yeah.
Is that the answer? Yeah. Now, what you could do is make a scale, make a graph. You know, you could graph it, and you know, you could do it that way. Well, I don't want to get into that, but yes, it's simply least common multiple. Well, let's not graph it, but we can say we did, but really not. But anyway, so yes, okay. So 70 days, is that right? Every 70 days they hook up. All right. So what do we got? Which number are we doing now?
14.
All right, when I woke up this morning, it was negative 5 degrees Celsius. Since then, the temperature has risen 17 degrees Celsius. What is the temperature now? Really? Negative 5 degrees Celsius. Temperature's gone up 12 degrees.
No, 17.
So what do we got?
17 degrees. It went up 17 degrees.
Oh, went up 17. Oh, sorry.
And the answer is 12.
Oh, the answer's 12. Sorry. Give away the answer. Write down the question. Right, okay. So if you're on a number line, 0, this is negative 5. So you're going to increase by 17. So you're going to end up here, which is 12, right? Easy?
Yes.
And so you can say that this value here is 17, right? Easy?
Yes.
With me? Are you okay?
Yes.
Sure?
Yes.
Would you see me after class for just a moment? Excellent. Okay. Next. Find the square root of, I cannot believe they're asking you to do this. Negative 16. The square root of negative 16, what is it?
Cannot be found.
Why?
Because this is negative.
Oh yeah, you can find it all right. You can find it. Yeah, you can.
Yeah.
Let me explain. May I explain? I'm going to go through this and you're going to say, what did you just do? All right. Do you agree, based on the laws that govern radical expressions, I can rewrite this as 16 times negative 1? Do you agree? Right?
Yes.
Okay. Do you agree that I could rewrite this as 16 times negative 1?
No.
I can't? Okay. Do you agree that I could write this 4 root negative 1? Correct?
Yes.
Yes, of course I can.
Yeah.
Now, does negative 1, can I find the square root of negative 1 in real numbers? No, I can't. So therefore we say it's undefined in real numbers. Now, let me explain this, okay? And we did this in 8th grade too. It's really weird we just did this.
No battery. No battery. No battery.
All right, I can, all right, let's not panic. I can deal with this. I have the technology. All right, no panicking. Nothing weird here, guys. This is very easy to do. Okay. I know everybody's having a little bit of a coronary. That's okay. All right. Now, the reason is, everybody, I'm going to show you this. I'm going to show you this. This is going to become very useful. And I think it's significant just for you to walk out of here today and know that the number system is more complex than you thought it was. No pun intended. See, the computer even agrees with me. Okay? Now, we have something called, believe it or not, we have something called the complex number, what am I doing? The complex number system. Okay? And in the complex number system, you have real numbers. Right? That symbol stands for numbers. Do you know that? Okay. Under real numbers, we have rational and we have irrational. Okay? Yes or no? You get it? Okay. Under rational, we have things like integers, whole numbers, counting numbers, etc. Do you understand that? Under a rational number, how do I define rational number? A rational number is any number that can be expressed as a fraction, a quotient, a ratio, A over B. All right? Where A and B are integers. Pick an integer. Pick any integer you like. Pick one. Paul. Pick an integer.
9.
That's really exciting. Plus 9. All right, pick an integer.
8.
8. Positive 8 or negative 8?
Negative.
Oh, you're getting wild on me. Okay, excellent. I like that. He's a wild guy. So that's negative 9/8, right? Right? Is that a rational number? Yeah, it is. Because I expressed it as a number, a fraction, A over B, where both A and B are integers. Easy? Kind of silly almost, that's so easy, right? Okay. An irrational number is defined as something that can't be expressed like that. What does that mean? Yes?
But if you can't express as fraction, you can express as division.
You can't express it as division. In other words, square root of 2. What is probably the most famous irrational number? Anybody know? What's that?
2. Pi?
Pi. Yeah, pi is irrational.
Huh?
Pi is irrational.
What's
You-
pi? It's like it's a perfect.
Don't worry about what pi is. You'll figure it out. And we're going to do a lab on pi this year. We're going to do a lab to discover pi. Okay, so
Like real pi?
this pi,
No,
yeah, the real
pi is
pi.
a number. Johnny.
So the square root of a prime number is irrational. The square root of a prime number is irrational, okay? Now, then, so you get it? You get it so far? You with me? A little bit? No, of course you're with me. You've heard of integers before, right? You've heard of integers before, haven't you?
Yes.
Right? You've heard of counting numbers. You've heard of rational numbers? Well, that's what you've been using. An irrational number, I just told you what they are. Square root of 2. Does that make sense to you? Square root of 2? Yeah, sure. Put in your calculator, square root of 2, and it comes out with a number, an approximation. Okay? Then there's another set called imaginary numbers. And you know what imaginary numbers are? Imaginary numbers are numbers that contain the square root of negative 1. You know what the square root of negative 1 is called?
No.
I. Sorry. So, under real numbers, that's all real numbers. All real numbers. If the replacement set is all real numbers, then does that have an answer? No. 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 If the replacement set is complex numbers, does that have a solution? Yes. I said it was 4 root negative 1, didn't I? Didn't I? If that is equal to that, what's the answer? Yeah. 4i. Means nothing to you, I know. It's like Greek. Well, it's not Greek, it's just Martian or something. In electrical engineering, for instance, do you ever hear of electrical engineering? Like electricity and all that stuff and design? Right? You know what math they use? They use this kind of math. Yeah. It's called field theory. If you become an engineer, you'll learn, and you do electrical engineering, you'll learn this. You'll use more math. You'll use this system as much as you use this system. Isn't that amazing? And for them to say to you, what's the square root of a negative number, that's amazing to me. Okay? I know, that's a little bit crazy. We just went a little wild. Okay, we went a little wild. I understand. We went a little wild. We went a little crazy. But that's okay. Okay, we went a little crazy. All right, what about the fourth root of 16? What's the answer there? What multiplied by itself 4 times will equal 16? 2. 2 times 2 is what?
4.
Times 2?
8.
Times 2?
16.
Got it? Easy, huh? Okay, good. What about, is 2743 a prime number? Is 2743 a prime number? Is it?
Yeah. Maybe.
Well, what's it divisible by?
It's divisible by 3.
By 3?
No, 13.
By 13?
And 3.
So that's going to be what?
1.
You're saying it's 2, 26, 1, 14, 1, 13, 1, 3, 1. Cool. Right? So is it a prime number? No. Is that the answer?
Yes.
Okay. All right, we're almost done, guys. All right, number 17. This was a long quiz, wasn't it? All right,
Yeah.
let's say 15 plus 5, 17 plus a negative 5 minus a negative 2. What's that? What's this part of it? What's 17 plus a negative 5? What is it? 12 minus a minus 2. 14. Is that right? All right. What about negative 1 cubed times 5 squared? Negative 1 cubed times 5 squared. What's that?
Negative 25.
Negative 25. Excellent. Excellent. Well done. How about negative 3 squared? Negative 3 squared.
Negative 9.
Negative 9. Excellent. Excellent. Negative 9. Excellent. How about 6 times negative 2 divided by negative 4? 6. What is it saying? 6 times negative 2 divided by negative 4. Is that right?
Yes.
Is that right?
Yes.
Is that right?
Yes.
Excellent. So negative 12 over negative 4 is 3. Positive 3. Right? Right?
Yes.
Okay. How about negative 3 divided by 9? Negative 3 divided by 9.
Negative 1 over 3.
Negative 1 over 3. Or negative 1/3. Can't you put the negative sign anywhere you want, really?
No.
Who said no?
She did.
What? All right. What about, hey, we're on the last one, guys. This is very exciting. How many people are like so excited we're almost finished? All right, let's go, guys. So 7 minus 16 over negative 2 minus 7. What's that going to be? 'Cause that's negative what?
Negative 9 over negative 9 is 1.
Negative 9 over negative 9 equals 1. We're done!